RobinaShaheen, RobinaShaheen. I'm working to find our signature of life beyond Earth.
So Robina, can you answer this question that seems to be on everybody's mind? Is there life beyond Earth?
Yeah, that's a very interesting question because you might remember about one of the movie where Judy Foster is in a contact. She was trying to find signal from the alien life. So what I do, I look at the life from the very preliminary point of view, how the life started, if it exists on any other planet, and what type of life it is. Do we understand it? And it goes like with NASA is searching for on other planets in our solar system. And I particularly am interested in Mars because this is our sister planet, looks like this Earth, and where water can exist. And that would be a very good place to look for life.
So what do we know about Curiosity that's been exploring Mars? What data are we receiving back about what we see there?
Yes, that's Curiosity is actually looking at the present day atmosphere and present day how the life would be right now. But what I do, because Mars atmosphere is gone in the past, now it has only very thin air, like if you go above the K2 and Himalayas, and that's UV radiation can penetrate in. And all the cosmic radiation, that million electron volts, it's very strong energy that penetrates. So on the surface, there won't be any possibility for any life to exist. And Curiosity is digging under the ice to find the life. But I'm looking if there is any past life. And for that, I use meteorite. Meteorite are chunk of space, like the rock from Earth. And I have, this is rock from Mars. And you may see they look the same, but using isotope, I can distinguish where this rock came from. And I also have signatures for living things and the non-living things, so I use those isotopes as markers, as a signature of different type of processes.
So in a way, you're reading the rock and the history of that rock, right? And what are some of the methodologies from that? You're talking about reading isotopes. How do you do that exactly?
That's a very interesting question because consider oxygen that we all day breathe in, but we never think of it has 3 isotopes, like 3 siblings. They have the same chemical reaction, but one is 16, the skinnier one, 17 is a little bit bulky, and the 18 is a really chunky boy. And once you can think all the chemical reaction, the light, it's running. And what happened during certain chemical reaction, they are dependent on the environment. So where 16 ends, where 17 ends, where 18 ends, that depends on the particular chemical reaction. And I can tell that how it happened, under what condition it happened, and that's give me all the details I need to know if it is done inside the living cell or outside the living cells.
So how did you become interested in this area of study?
Actually, that was, for me, every time I look around the history of Earth, that life started 3.5 billion years ago, and we are such a conscious being who wants to know everything. And the single cell, a bacteria, has the same component that we have. And how life evolved, can we understand first cells, how it developed? And for this, it might be, if we know the first building block, we might be able to find more application in our life to cure so many things, how things work. And having that first knowledge about first cell, how it formed, and there may be a possibility that what we think life on Earth, it may not be the same anywhere else. So that's a very fascinating question to me, what life is.
Well, hopefully your research will give us those answers, Mars.
Thank you.
So much.